I'm Erica. Have you ever heard someone say that they received their daily dose of serotonin? Normally, they're referring to something in their day that brought them joy, something that raised their mood. Serotonin is so much more than an experience that brings someone joy. It controls so many of our bodily functions like metabolism and our sleep cycle. Speaking of metabolism, I'm pretty hungry. I think I'm gonna have some pistachios. For me, those pistachios were my daily dose of serotonin. As you can see from the nutrition label, pistachios carry a large amount of protein. Amino acids are the main building block for proteins. And you know what else amino acids are used for? The construction of serotonin. Pistachio acts as this resource for amino acids or proteins to enter my body. The essential amino acid associated with serotonin is L-tryptophan. The L-tryptophan undergoes a process of transformation that turns it into 5-HTP, 5-hydroxytryptophan. This can also be coined as serotonin. You can see here, the pistachio acts as this resource for my body to produce serotonin. The location for distribution of serotonin is located in the brain, specifically in the raphe nuclei. Serotonin neurons can be found in clusters of the neurons in the brainstem. The brain is part of the central nervous system, the nerves that go through the whole body and make up the peripheral nervous system. This means that the serotonin generated in the brainstem travels all throughout our body, helping more than just our mood, but also systems like gastrointestinal system that controls our metabolism, and the vascular system that controls our blood flow. Let's see how the serotonin acts in our neuron. I've shown a ton of tiny red dots representing the neurotransmitter serotonin traveling down the axon. The neurotransmitter from the presynaptic neuron travel down the axon to the terminal, where they are grouped into synaptic vesicles, shown here. Eventually, these serotonin neurotransmitters need to be released. They are released through the synaptic cleft in an exergonic reaction. They bind with the G protein coupled receptors. Here, for the sake of this video, I'm showing a larger version of this neurotransmitter serotonin binding with the G coupled receptor. The serotonin acts as the ligand, and the G-coupled receptor is the receptor of this ligand. This bond changes the shape of the protein, which then sends a signal to the G proteins inside the cell, shown here. For the sake of this demonstration, I have enlarged the receptors and ligands, shown here, and here I have the plasma membrane, since the receptor is located on the outside of the plasma membrane. The serotonin enters this receptor, and once the two ligands are bound to the ion-gated channel, they open up the channel. However, the signal created by these ligands can either open or close the channel. The channel opens, depolarization occurs, which allows sodium ions to flow through the ion-gated channel and into the cell. As these ions enter the cell, they act as the signaling for the rest of the central nervous system. Serotonin, as a neurotransmitter, works to control nerve impulses. A change in this process can result in many major neuropathic disorders. Serotonin is the queen of our central nervous system. It controls all of what we do and all of what we do. Since the brain controls everything that we do, and serotonin is generated in the brain through the central nervous system, serotonin helping with sleeping, eating, and digestion is no surprise to us, and we should be grateful to have serotonin in our system. Thank goodness for the synaptic signaling of serotonin.